We discussed the base rule, and we need the rule of the total probability to get the probability of the B. And I think we did this one, right? It's a long disease, right? Yeah. So we have the last example. So please read it. The last example. You know, have you ever bought eggs at the grocery store? Yeah, we have a box, it's carton, a dozen. There's 12 eggs, right? But when you buy the egg, do you check all eggs? Yeah, why not? Yes, yes. Is every single time my wife asks me buy eggs on the way home, always she suggests me open the box, check one by one, right? Yeah. So we have to. Yes, 78%. Yeah, in the refrigerator, 78%, no broken egg. Good one. But sometimes we have one broken egg in the carton, in the box, right? 19%. One of them is broken. 2%, sometimes two broken eggs. And yeah, let me consider. Let us consider it's up to 3. Yeah, it's 1%. The 3 broken eggs. It's good, right? So now we can make the Venn diagram. We can make the Venn diagram, and we can split A1, A2, A3, and A4. So the A1 means no broken eggs. A2, 1 broken eggs. And A3, 2 brokens. And A4 is 3 broken eggs. The A's are mutually exclusive and exhaustive. Exhaustive means when we sum up, merge them together, it will be same as the sample space. It's good, right? Okay, now we need another event of the B. So let me in the middle. Here's a B. What is a B? When I select an egg from the given carton, given the box, I found a broken egg. So let me take an event, found a broken egg. So look at this. My wife suggests me buy eggs, a dozen of eggs. I should open it and check all of them, but I didn't. I already paid. But in my heart, I remind my wife saying, open it and check them all. So in my car, it's already I paid. Let's open them. I found, oh my God, one is broken. Okay? What do I need? I want it is the only one. You understand what I'm saying? Right? Yeah. So yeah, the event of B, I found a broken egg. Okay, good. Oh my God, I might have 2 more. Right? Already I found one. There's a 2 more. In this case, 1 more is actually in the box, in the carton. Carton is already there is a 2 broken eggs, but I chose one of them. So in this case, there is one more. Oh yeah, it is the only one. Okay, good. Just a second. Can I look for a broken egg here? It means in case A1, actually there was no broken egg. Can I pick one? Can I pick broken egg? No, impossible. So let me modify, let me change the Venn diagram. On the A1, oops. On the A1, we cannot pick a broken egg because inside is already there is no broken egg. Does it make sense, right? Yeah. So we have to, but still it is a B. Yep. Yep. The circle in the middle, it is an event we found a broken egg. So now I can say the probability of A1, 0.78. Probability of A2, I pick a box which has one broken egg, that is 19% from the refrigerator, and there is a A3, 2%, 0.02, and A4, that is only 1%. Can you add up? Please add up the 4 possible probabilities, please. How much will be the sum up? It must be 100%. Always. The event of A's must be disjoint and what? Exhaustive. Exhaustive means when we make them up together, it must be same as the sample space, the rectangle, 100%. Yeah, why not? Yes. Okay, what do I need? Already I found a broken egg, right? Yeah, I didn't check inside of the store, but I already paid. But now I found it. I found a broken egg. What do I need? I hope it is the only one. A2. A2 given B. You know, I told you when we need the probability A given B, and I suggest you please remember A given B, we have to apply the base rule, right? So let me apply the base rule. By the base rule, it will be same as the probability of A2, probability of B given A2. In the denominator, we need the total probability. We need the sum of the probabilities, which will be probability of A1 times probability of B given A1, add probability of A2, probability of B given A2. And probability of A3 times the probability of B given A3, and one more, probability of A4 times the probability of B given A4 in the denominator. In the denominator, we need the 4 terms, the sum of the 4 terms. Okay, it's good. Okay, now we applied the base rule, and the denominator at the bottom, we apply the rule of the total probability. So now we have to look for one by one. First of all, can you give me the probability of A2? I need a probability. I picked the case which had only one broken egg. What was the chance? In the refrigerator, we knew 19% of them. Already they had one broken egg. The probability of A2, it will be 0.19. Okay, now I need the conditional probability of B given A2. Just a second. Be careful. A2 given B. What does it mean? Can you interpret? What was given? B was given. What was that? I found it. I found, I didn't check. I didn't check inside, right? Now it's outside of the store. But now I found a broken egg. And we need a chance. It is from A2. It is the only one. No. We are going to finally we are going to take the conditional probability. But now I'm explaining to you what is the interpretation of the conditional probability. Already we found the broken eggs. We need a probability. It is the only one. It is from the case which had only the D1, the broken eggs. But now here, A2 is given. What does that mean? Already we knew I bought the case. So now I think this one is the situation. I checked inside. Already I knew it. Already I knew I bought the case A2. So already I knew, oh yeah, there is one broken egg. And now what? What is the chance when I randomly choose one of the eggs from the case? What is the chance the selected one is broken? How do you think? What is the conditional probability from A2? What is the chance I choose the broken eggs from the case? How many broken eggs inside in the box? 1 out of how many eggs? 12. So the chance I select randomly a broken egg from there, 1 out of 12. And actually 1 out of 12 was not given in the example, but we can figure out because we knew A2. What is the A2? Already we knew there is a 1 broken egg out of 12. And now we need a probability. I pick the egg, the broken egg, 1 out of 12. Does it make sense? Right? So the probability of B given A2, that is a 1 out of 12. Probability of A1, what is the chance? I pick the box, the carton, no broken egg, 78%. From the refrigerator, with the chance 0.78, I can pick one, the good one. Again, from the case, what the case? No broken eggs. Can I find the broken egg? Impossible. Then how much would be the conditional probability? Impossible. That would be 0, yes. And the next one is the same as the numerator. It's a 0.19 times 1 out of 12. And probability of A3, 2%. And now, what is the probability I pick a broken egg? Based on the case A3. What was the A3? 2. Already I knew there is a 2 broken eggs. What is the chance I pick one of them? 2 out of 12. And the last one will be 1% to select the carton, which had 3 broken eggs already. And the chance I pick a broken egg is a 3 out of 12. So now can you look for one by one, case by case, and understand why it is impossible, right? Because already we knew there is no broken egg, but impossible to pick one. Okay, then let me take one by one as a 19.19 times 1 over the 12. I have a 0.0158. Yeah, I'm using the 4 decimals because even when you are doing the homework, yeah, please use as many as decimals, right, for the rounding problems. So in the base rule, it's so many times we have to take the multiplication, the division, summation, rounding, 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 rounding. So it is easy to take the rounding mistake. So that must be 0.0158. And the first one in the denominator, it must be 0. And the second one is the same as the numerator, 0.0158. And the next one is a 0.02 times 2 over 12. I have a 0.0033. And the last one will be 0.0025. And let me take the sum. Yeah, I just keep the numerator is a 0.0158. Denominator will be 0 plus 0.0158, 0.0033, and 0.0025. Yes, the denominator will be 0.0216. Finally, we can take the ratio 0.0158 over 0.0216. That is the 0.7315. That is the final probability. What? When I check after I paid, but I found a broken egg, 73.15%, it could be the only one broken egg. 73.15% chance the other 11 eggs are good. The other way I can interpret, I have a 73.50% chance I will get a dinner tonight. You understand what I'm saying? So remember, always when we need the probability A given B in this order, we can apply the base rule. For the base rule, always the B given A's will be given. So using the order as a B given A, we can look for the switch conditional probability as A given B. Okay, so it is the base rule. Any question? Do you have any question from the homework? Any problem? No? Let me try one more. Is one of the questions in the homework number. Already I posted the homework number 10, right? So today I want to finish up as a chapter 4. Discuss the base rule again. So I want to pick as one of the homeworks, one of the questions, number 5 from the homework number 9. Number 9 is due tonight. Okay. Okay, here's a number 5. Here's a number 5 in homework number 9 tonight. We have 2 columns. This one is the percentages by age group. And this one is another probabilities for the overweights and obese by the age group. Okay? Can you take a sum, please? Yeah, please take a sum. 100%. When I make the tree, when I make the probability tree, just a second, let me. Oh, just a second, I wanna fill up solely. Yes, good. When I make the tree, then it must be. Here's the age group 1, 2, 3, and 4. The A1 is the 18 to 34, 35 to 49, and 50 to 64. And the last one is the over 65. And I have to plug the probabilities here. It's a 0.429, 0.288, 0.161, 0.12, and 2. So when I sum up, do you remember that? The fact? When we sum up the probability of A's, it must be 100%. And now the second column is actually the second column is the event of B. So now additionally we can split it's a B here, overweighted, not B. It's a overweighted, not B. Overweighted, not B. And B and not B. So the probabilities in the second column is must be 0.414, 0.563, 0.692, 0.55, 3. And the other probabilities for not B were not given. But we can figure out. Remember that? It's not only the sum of the first 4 probabilities, but also these two must be another 100%. Another 100%, another 100%, and another 100%. Do you remember that? Right? So even the second conditional probabilities are not given in the example, in the question, but we can figure out the others. And then what? We can apply the general multiplication rule. We can take the joint probabilities in the last column. So let me try. When I go back to the question, one day I explained to you what is the function of the small blue circle, right? The link. Then when I click the blue one, then we can open the table in Excel. Do you remember that? And now I can open them in Excel. One day I explained the button, and I suggest to you, you have to install the MS Office 365, the local computer, right? And I emailed you the link. So if you lost it, or if you want to get a game, yeah, please email me. I can give you the link again. I'm sorry. There are percentages, but we need the probabilities. So let me take the probabilities is divided by 100. And just copy down and copy to the right. It's actually the column E is a probability of A's. And the next one is a probability of B given the one of the A's, case by case, right? So you checked the sum of them is 1. And now here, I want to take the A and the B, the joint probability by the general multiplication rule. So in the column, take the multiplication, the probability of A times the conditional probability of B given A. How much do you expect the sum of them? No. Why not? Because I didn't take care of the second one, right? Actually, the last one must be 4 by 2. in the last joint probabilities must be 8 combinations, but that is only 4 of them with only the B, and not without not B. Do you understand what? Yeah, why it is not? Yeah, yeah. But it must be what? It must be just the probability of B by the rule of the total probability. Do you remember the rule of the total probability? Which was the summation probability of AJ times B given AJs. AJs, yep, they are here. The conditional probabilities is over there. And the multiplication, yep, that is here, right? So the probability of B is the sum, 0.5186. Okay, so let me go back to the question number 5 in the homework. Then what? In part A, what percentages of overweight? What do I need? Does it depend on the age? In part A, it didn't ask us about the age. Age, it doesn't matter. Then what? We need just the probability of B. By the rule of the total probability, part A asks us what is the probability of B. How much was it? 0.51863. Oh, be careful. Percentages. 51.863%. How many decimals? One decimal, just a second, just one decimal. 51.8. 52.0. Does it make sense, right? With one decimal, with the roundings, it must be 52.0%. Oh, 51.9. Yeah. I can try again. No problem. Must be 51.8. Must be the first decimal. Rounding up is 9. Good. Good, right? Yeah. And how about the next? Okay, here it is. Next one. Of those who is between 35 and 49. What do I need? I need the probability. I need the percentages are overweight. Can you write the notations, the probability notation? Is it B given A2 or A2 given B? Now it must be either one. Probability B given A2. Yeah, we assigned this one is the B and the 3549 is A2, or A2 given B. Which one? Number 1 or number 2? Actually, we need the percentage is what? Overweight. The B. Of whom? Between 35 and 49. We need this one. Okay? Yeah, please ignore the second one. Maybe the second one, you can be asked in part C, right? So it's not this one here. Yeah, that one. B given A1. Just a second. When did we apply the base rule? Is it B given A or A given B? We apply the base rule in the order A given B. But now in part B, we need the B given A. We don't have to apply the base rule. Then what? It was the conditional probability B among the age group 35 and 49. This exactly. So simply I just pick the conditional probability in the second column, 56.3%. Yeah, we don't have to apply the base rule because it is the B given A2. So now simply I pick the second one, 56.3%. Does it make sense, right? And now look at this. What? Now what? Can you see that? Of whom? Overweight. Given B, right? What do we need? What is the percentage is? A2. Now it is A given B. Now it is A given B. So now let me go back to the problem. In part C, we need the conditional probability. It's actually the switch conditional probability. A2 given B. And now we need the base rule. We apply the base rule. Probability A2, B given A2. But in the denominator, it's actually we need the sum. But actually, who was that? Who was the sum? The sum was this one. Who was probability B. Already we take the probability B in part A. In Excel, it was 0.5186 in the denominator. 0.5186. And now we need only the multiplication. A2 times B given A2. How much was? How much was it? A2 times B given A2, which was 0.1621. So we can plug the probability, the multiplication, 0.1621. That will be the conditional probability, switch conditional probability A2 given B in part C. Good? So do you have an idea? When can we apply the base rule? How can we apply the base rule? Good, right? Good. Any question? Do you have any other question in the homework number 9? It's actually the homework number 9 had 5 questions. Yeah, to apply the base rule. And the homework number 10 is today's one. It's due Wednesday. And it's another more questions about the base rule. So today you should understand what is the base rule is clearly. No more questions? Let me announce you one more. Yeah, it will be the last one. Okay, please look at this. Please remind this question. Here is the conditional probabilities, and here is another conditional probability. So now 0.90. That was the probability of B. I mean the B is the smoking. Given A, the lung disease, A2, and 0.253, that is a probability of B given A1. They were given, and we found the probability A2 given B. Good, right? Do you remember? Okay, now I want to compare the two probabilities. This one and this one. Let me see. 0.90 among whom? Among the people, among the group who has the lung disease, right? This one. Of whom? Who is given? The B is given. What is the group of B? Smokers. Okay? When I comparing Who has the lung disease? Who are smoking? Think about this. Patients. Where is the patient? Where is the patient who has a lung disease? You don't know? Usually, where is the patient? Hospitals, yes. When I visit the hospitals, the specialized lung disease, there are so many patients who has a lung disease. Not even visit the hospitals, just visit the doctor's office. It's not only the lung disease specialist. Have you ever visited the doctor's office the very first time? Yeah, it's somebody gives us many documents, right? And the address and the information of the insurance and the background from my parents and oh my god, yeah. Even we visit the doctor's office, it is very easy. It is very easy who has the lung disease, right? Yeah, there is a record. So many patients who has the lung disease. But think about this. Who do we need? We need the smokers. Patients, doctor's office and hospitals, we visit there. It is easy to get the data, right? But where is the smokers? You mean the not inside campus? Okay, don't smoke on campus, not in the building. Outside, where?
Anywhere.
Okay, anywhere. But you know, I need many smokers. Where is a good place I can meet the many smokers?
Concerts.
Oh, concert.
A bar?
Concert. What?
A bar?
Oh, bar. That is a good place. Yeah. The bar, right? Oh, how about the casino? Oh, yeah, across the river.
Yeah.
Have you ever visited? Oh my God, the smell. Not so good, right? Yeah.
They can't smoke in them right now.
Okay. Yeah, good, good. Yeah, that is a good one. But let me visit the two places. Bars, casino, right? There are so many smokers. What do I need? I need if they have the lung disease or not. See, we need the probability this one, right? So okay, good. Let me visit the bar at night, Friday. And yeah, who there is how many people is smoking and drunk? And I have to ask them, sir, excuse me, you are smoking right now, and may I ask you, do you have any lung disease?
No one's gonna. No one's gonna know they'll get hurt.
What happens? Punch me? Go out! How about the casino? Lose the money? Oh my god, another day. Man, you're smoking right now, but yeah, you have no answer. Okay, what I want to say, it is harder. I need the probability harder. But how about that? It's easier. Just visit the hospital or doctor's office and look for the charts who has a lung disease, and also they ask me, do you drink? How many times a week, a day, right? How much? Also, are you smoking? Every single question, right? They ask me, smoking, drinking, or some other drug, something like that. It is much easier. But why we need this one? Anybody who is smoking, everybody may be concerned. Not only the smokers, but most of the researchers, they want to get this one. But this probability in this order is harder to get. But by the base rule, with the easier conditional probability, we can take harder conditional probability, the switch. So fancy. It is so good, right? Yeah. So finally, I just explained to you why do we need a base rule, right? Yeah. So using the easier conditional probabilities, we can take harder conditional probabilities. Yeah, I'm so sorry. It's boring. Yeah. So here's a homework. I'm sorry, the quiz number 10. Okay. Yeah. Try it. You don't have in part A. Why don't you make the tree? Yeah. Please. Yeah. Here's the paper. Do you need a paper? Okay. Here's the paper. Yeah. Please make the tree first, and take the conditional probability. Did I give you that? First name is number. Everybody got yours? Yours back? No, I'm sorry. Last name. Anybody else? Okay, now let me try. How many splits at the beginning? We have two codes, dot or dash. Do you know what is the most code? Ding, 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 right? Yeah. So we had only two, A1 dot sent, or A1, A2 dash sent. But Morse code is a very old one. But these days we have a 5G, but long time it's wires, it's very old or something, right? So sometimes the dot sent, but we received. Most of the time, we received is correct. What does it mean, correct? Dot sent, dot received. But sometimes, I don't know why, but not B. Incorrect. It is the same thing. When dashed, sent, but sometimes is correct. We received the dash, but sometimes we have dot. Incorrect, not B. So now, can you plug the probabilities? What is the chance? Dot sent. It was given. 3-7. Yeah. The probability is dot sent is a 3-7. And what is the chance? Dash sent. 4 out of 7. Yes. So we plugged 3/7 and 4/7. How much would be the sum? Must be 100%, right? Let me see. Suppose there is the with the probability 1 over 8. What is 1 over 8? Mistake. So which one must be 1 over 8? Incorrect. It's 1 over 8. Incorrect. 1 over 8. Both of them, dash, dot, has the same probability. Mistaken. Then how much will be the chance correctly taken? 7 over 8. Yes. Additionally, can you take the joint probabilities in the last column? Yeah, please do by yourself, right? Yeah. So far so good. Any questions?
Oh, no.
You good? You good? Okay, good. Please complete the last column. It must be 3 over 7 times 7 over 8. And 3 over 7 times is 1 over 8. And 4 out of 7 times is 7 out of 8. And the last one will be 4 out of 7 times is 1 over 8. Then what? What do I need? In part B, it is a part A. And part B, we need the probability. If we received dot, and we need the probability dot sent, and we received correctly. Can you interpret? Can you interpret the question? I need the probability dot sent when we receive dot. What does it mean? We receive correctly the event of B. So now the order is A given B. Absolutely, we need the base rule, which will be probability of A1, probability of B given A1, and probability of A1, probability of B given A1 repeat, but add probability of the other case, A2 times the probability of B given A2. Then you can plug it one by one, case by case, right? And take the multiplication, summation, fraction. Yeah, it's a finally, yeah, you can get the probability. Any question, ask me. Good. Today, I will email you the lecture note for chapter 5. From coming Wednesday, we are going to discuss the new chapter 5. Today we done chapter 4.
Yeah, it's the same. Mine's just doing 749.
You need the pen?
Yeah.
Where did you get this? Already you got this one. So now you can say it is the probability A1 and B. It is.
This one?
No, what?
130 or 175.
I think already you did the multiplication, right? Yeah, it is, no more. Yeah.
It's basically 0.5. 500 and 0.875. Could be wrong. What did you round it by? December decimal? Yeah.
언제 돼? 아웃.
Wait, that's what I'm. I don't know. Yeah, I just looked at it.
Me?
There you go.